It's unbelievable how important this is. Okay. So a small square, if you actually measured it, it would be 1 centimeter by 1 centimeter. Now we call these algebra area models because what would be the area of this piece? Well, 1 centimeter by 1 centimeter, and area is length times width, or s squared, right? We do have a square. So we multiply 1 by 1, it would be 1 centimeter squared. Okay. So we actually call this the name of the size of its area. We call this the 1 tile. Okay. Now the opposite tile, for us, if we shade it in, we call that the -1 tile. And you guys have colors, don't you? So one color would be, and the other color would be negative. So the colors tell you whether they're positive or negative. Okay? Good. Then we have a rectangular tile. I'm just using a different color because I feel like it. If you measure this side, what would be the dimension of this side? See if you have something you can measure it with. Yeah, exactly. Now, how long is this side? How much? 5? Any other answers? 5.5. Any other answers? 5 1/3. We'll round it to 0.3. Any other answers? What's the exact answer? Do you guys know what the exact answer is? Yeah, me too. 10? I'm not sure what you're measuring. Maybe you're measuring both sides, putting them together. But just one length, it wouldn't be 10, okay? 5.5, 5.3. Do you know the exact answer? Who said yeah? What's the exact answer? But other people are saying 5.3. Prove that's not 5.3. No, just use what you got. 5.25. Sounds to me like you're guessing. What should we call it if you don't know the exact answer? No. We'll assign it a number. X. Assign it a letter. Okay, so we'll call that X. So the dimensions are 1 centimeters times X centimeters. So the area, length times width, would be 1 times X, which we call X. So this has a really fancy name. Are you guys ready for this? The X tile. Crazy. Unbelievable. What about the opposite tile? Nope. Oh, so if we shade it in, then we'll call it a -X tile. Good morning, Michael. Okay. What about the large square? What would be the dimensions of the large square now? See if you have, use the other pieces to measure it. Are you guessing again? Oh, we got some brilliance up here. She measured it as X times X. That's the actual dimensions. It's an unknown length times an unknown length. So the area, again, length times width, for us it's X times X. So it would be, come on, you just finished your exponents. What's X times X? X squared. You add the ones, right? You add your exponents. Now, this has an even fancier name. You guys are starting to get this. It's the X squared tile. Okay. And the opposite tile, now, what will we do for our drawing? Shade it in. And what will we do for the name then? Oh, you guys are getting this. Okay. Perfect. Yes, Victoria, question. We're stretching. You guys like to stretch in this class. Okay. Any questions so far? So if we're drawing, and this is the key that we're using. Now we want to totally mess you up and screw you up. So let's go to the textbook. They use something a little bit different. Go to page 177. Answer these questions, please. So you only need one textbook in both of you, or I'll give you 2 minutes. Go. I'm not sure how you can read the textbook when you're staring at Michael. So, what colors are you using in the text for the one tiles? Michael. Like on page 177, what have you been doing for the last 2 minutes? So look at page 177, look for the small tile that they call a one tile, and tell me what color they use. Red or white? Connor? Who? Really? That long? How much time? What's the answer to the question? What have you been doing for the last 2 minutes? It helps if you read the page, though. Can you locate those small little squares? Page. What color? Okay, which one is for the one tile? Which one's for the negative one tile? Thank you. Okay. So red would be for the one tile. +1, sorry. And the white is for the negative one tile. Next time, don't just read it, write it down. Which tiles are used for the x and x squareds? Victoria?
Positive is green.
Good. So green is positive, and white is negative. Okay. Why do you think different colors are used for the one tiles, comparing that to the x and the x squareds? Like, why were they using red for the +1? I mean, what do you think?
Because the one tile is the same shape as the x2 tile.
But then how come you don't use the same colors? Right? Because like if you look at the x2, it's still using green and white instead of red and white. What do you guys think? Just guesswork here. Yeah?
They're both unknown.
And what about the one tile?
It's a number.
One tile has
Yeah, you know its area, right? Okay, so the one tile, that's an exact area. Whereas the x and the x squared, that's an unknown area. Okay. I'm never going to test that. The only reason I bring that up is just so that you guys can have your curiosity satisfied, right? So if you're kind of wondering why, well, that's kind of why. Is it a big deal? No, you don't really need to worry about that too much. Now, there are Y tiles, but we don't use them. What make they look like? Any ideas? Circular. Good guess. No, they aren't. Okay. Remember their areas. So one of them was actually the same 1 centimeter. Okay. But what about the length? Any ideas on that? Sorry, someone said something?
Don't know. But it's like maybe it's under one.
Ah, so you don't know, but you're thinking of something. What are you thinking?
Under one.
Under 1. Close. You're on the right track.
Over one?
Sorry?
Over one?
Over 1. So you're saying they're really small? Like that? Could be. It could be. But what would you be comparing the Y tiles to?
The X tiles?
The X tiles. So what would they look like in comparison to the X?
A little bit longer.
A little bit longer or
Smaller.
smaller, and that would mean they have to be different, right? So they would be different than the X's. And in fact, it's actually shorter, I believe. Okay. So I believe for us, the Y tile, it's a little bit shorter. Okay. I think it's also they use yellow and white. You'll see that in one of your homework questions. I'm not exactly sure though, okay? But you'll see something different. They'll be calling it a Y tile. Then what about an XY tile? What do you think that would look like? Yeah. Two what?
Two different, it's like a different width and just a length.
Ah, so what would be its length and width? Think area, X and Y. So one side would be length X and the other one would be length Y. Oops, I want to make it clear that the Y is shorter, okay? And I think this is gray and white. Gray is positive, and I believe white is negative. Okay? I believe that's what it is. But you'll see that in the textbook. Okay, and we don't really draw those. They just kind of talk about them a little bit. And it's no big deal. All right? I don't quiz it. I don't test it. But just to let you know, they do come up. Any questions with this so far? Kind of got the basics down. So let's start having some fun doing some work. Turn it over. So we have how many x squareds? 1, 2, 3. So we simply write down 3x squareds. What is this 3 in front called? Coefficient. Okay. So the coefficient tells us how many there are. There's 3x squareds. What about a negative 2x? Well, how many are there? 1, 2 of them, and they're negative, so it's a negative 2x. Okay? So you have to understand that these belong together. They're telling us all about the x tiles. It's negative and there's 2 of them. And here we have a +1, and guess what? It's not shaded, so it's a +1. Okay? So you have to be able to go back and forth from one to the other. So what I want you to do right now is I just want you, with your pieces, move it around, create that with your partner. Go ahead, 3x + 2. You can draw them any way you want. You can draw them so that they stick together. Now you have a 3x + 2 length. Okay, so you can do that, or you can just draw 3x square tiles side by side and 2 little ones. Okay, but I had some grade 10s tell me that, oh, these are the exact same, right? And they're not. So you got to show a clear difference when you're drawing them. Okay. Any questions? Okay, try the next one. B, go create it first. One, you should have a tile that you're calling negative x squared, so it's a big square that's shaded for when you draw it, and then a little one that's also shaded. Okay, now you don't have to go crazy with your shading, right? But again, it should be clear what's shaded and what's not. Okay, I look at that and I clearly see, hey, you tried to shade those in, they're shaded. Okay. Okay, try the next one. Create the trinomial 2x squared + 3 - x. First of all, I look at 2x squared plus 3 plus x and I cringe. Why? Why is that kind of written weird?
Oh, I didn't hear.
Sorry?
I didn't hear what you said.
Why is 2x squared plus 3 minus x written weird? Have a look at the degrees. Taylor, what do you think?
Wouldn't the plus 3 go at the end of the suggestion?
Yeah, exactly. This is a degree 2 term, degree 0 term, degree 1 term when you look at the exponents. Okay, that's not a proper order. So it's better to go 2x squared minus x plus 3. Okay? So when we're drawing that, here's a 2x squared, two big squares, a negative x. How do I show that it's negative when I draw it?
Shade it.
Shade it. So I should see that you attempted to shade it. And what about a plus 3? Do we shade these little 3 squares? No, because they're positives. Okay? Good. What expression? Now we're going the other direction. So now I give you an area model like this, and you have to tell me what does it represent. What is it? Meaty? How many x squareds are there? 2. How many x tiles? Dion? 3. And what's so special about those 3 x tiles? They're negative, so you have to put the negative sign in front of the 3. So where does the negative sign belong? The negative sign really belongs to the 3x. Okay? So that's a really important concept to know, is that negative sign belonging to the negative 3x. Okay? What's the length of the rectangular model? So what is this length here? What's this dimension?
X squared minus
Nope.
351.
What is this dimension here? What's that length? What's this length? What's this one? 1, 1, and 1. Now technically they're negatives, so we call it 2x minus 3. It's kind of weird that you get negatives. Now I think the textbook might even call them positives. I'm not too concerned. We fix all that in grade 10. We don't worry about it. Okay? So I'd make it very clear what I wanted. Okay? What's the length of the following area models? So I would say it's negative 4x plus 1. What's the length of the next one? Negative 2x minus 2. Okay. Now in the textbook, just beware, they might just say, oh, we shouldn't have negatives, it should always be 2x plus 2. So they might be doing that. I don't really like that too much though. Okay. Good. Question for you. Why do we not write a plus or a negative 1 coefficient in front of the variable? So in other words, why do we write negative x, not negative 1x? Yeah. The 1 is not needed. Right? Why, though, do we have to write a plus a 1 for the constant, like x plus 1 or x minus 1? How come we have to write that? Like, can't we just leave it blank and know that the 1 is there? No. Okay, it must be written. Okay. How are the different shapes related to different terms? So what 3 shapes do you have? Big square, small square, rectangle. How many terms do you have? 3. So what can you say? different shapes are different terms. Okay. Good. So, let's fill out this chart, just like we did at the warm-up. Go for it. Okay, try to fill it out right now, and we'll go over it in a second. Okay. We get some more time? Oh, sorry, more time. Number of different shapes. How many different shapes are there, Marianne? Good. Number of different terms. Noel. Good. Name of the polynomial. Michael. Awesome. What is or are the variables? This is a tough one. Kyle. Good. That's it. Right? X and x squared are the same letter, folks. We don't care about the exponents. We just care about the different letters. So these are just different letters. Okay. Good. How many x squared terms are there? Nicole? 3. What is the coefficient of the x squared term? Nicole? 3. How many negative x terms are there? Melanie? Good. And so the coefficient -2. Got that? A little bit different there, right? 2 negative x terms, -2. What's the constant? Doing? 6. And so then, what's the expression? 3x squared minus 2x plus 6. Okay, so we put it all together. So if you look at the diagram, you should be able to go from the diagram and back and forth. Any questions? Okay, please right now